I have two questions before we look into the topic of free fall. The first question being, what happens to a ball just left in the air? What happens, guys? So I'll say this is Earth's surface and you hold a ball somewhere over there. What happens to this? Okay, I'll draw it over here. What happens to this? Yes, it will get pulled down towards the Earth. Why does it fall? The next question is, why does it fall? With what law can we explain this? Yes, universal law of gravity. We have understood that gravitational pull is one of the fundamental forces in nature. Say I have an object of mass m and Earth has its own mass m. So two objects which have mass will get pulled by each other because of gravity. Okay. So the gravitational pull will see to that the ball falls towards the Earth. And now we will understand the topic of free fall. Free fall as a definition is this: an object falling freely under the influence of gravity is said to be in free fall. Actually, I have a better definition. Let me show you guys that. This is the better definition. A freely falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. Yes, it's a bit wordy, but this is a better definition. So read the definition. I have a small question for you guys, and post that I'll explain the free fall definition and give you guys a good idea about what is it. So I would like you guys to read the definition, try to understand on your own, get a feel of it, then try to answer this particular question. Both can be right or just one of them can be right. Okay guys, so please read the definition and then answer the below question. Okay, so what is it? Answer is option 2. Let me explain why. A freely falling object is any object. It can be any object. It can be me, you, a plane, a bird. It can be anything which is moving freely under the influence of gravity alone. That is, there's no propulsion. See, here in the first case, the engine is on, right? So the plane will be falling towards the Earth, right, with the help of the gravitational pull and also the push by this engine's flight or the engine's power, right? The engine also will pushing the air back, so the plane will go forward. So there is a combined effect. But in the second case, the engine is off. So the engine per se is not pushing or pulling, nothing is doing. As a whole, the plane is being pulled down by gravity and the plane will fall towards the Earth, right? So anything that is falling towards the Earth, provided there's no push by any other source, right? It's said to be under free fall, regardless of its initial motion. What does that mean? Say I have a ball, instead of just leaving it in the air, just letting it go, I throw it, with some force. Post I throw it, there's nothing pushing the ball pulling the ball other than the gravity. So the gravity will be pulling towards its center. So even though I threw it initially, even then it's said to be under free fall. Please understand that. Even though I threw it, from that point it's said to be under free fall. You just let it go, or if you throw it, right, even then it's said to be under free fall. But in this case, in the first case, the engine is on, it's pushing the air and the air is pushing the plane forward and all of that is happening. So this is not under free fall. A person in parachute, even this person is not under free fall. Okay, because the air is pushing him up, so he's slowly falling towards the Earth. So there are two forces acting over there. So even this is an example of not being a free fall. Okay, so I hope you guys understood what scenario is a free fall. See, it's just a scenario. It's just falling. That's nothing else, right? But with a particular condition that it just has to be gravity. That's it. Okay, guys, it's very simple. Why is that we are talking about this in a separate topic? Because a lot of things are under free fall. Okay, a lot of things which are not something which we think about it day to day, but they are under free fall, but they influence a lot of things in our lives. Okay. Now, some statistics about free fall, some basic data or understanding about free fall. See, anything falling, it needs to have a direction. It needs to have some strength with which it falls. So we're trying to answer that question. So now, say we have the earth over here, right? I have an object at point A, point B, point C, and point D. A, B, C, D, right? I think I told it other way around, doesn't matter. So I'll draw objects so that it's easier to discuss. Okay. In which direction do they fall? Object A will fall like this, object B will fall like this, C and this, and D and this. Right? Is that correct? No, right? Why is it not right? It looks right. Everything is falling down. Well, that's where we are wrong. See, downness depends on where you're standing. Down is always towards the center of the earth. How can I explain this? This is explained by universal law of gravity. What does the law tell? We have to join the centers of the object, joining the center, right? Joining the center, joining the center is the direction in which the object will fall, right? So in this case, it would be something like this. Again, we just need to imagine that we are joining the center. You can join the center and then draw. That would be more appropriate. For now, I'm doing it so that we don't waste much time. Okay. So the object will be falling towards the center. Let me erase this so that you guys are not confused. It's falling towards the center. All of them will fall towards the center. Right, guys? So think about it. We are somewhere along this line. A bit above the equator. We are along this line, the longitude, latitude. I don't know exactly what is the longitude and latitude at which each of us are, but of course, there's a definite longitude and latitude in which most of us live. Of course, there are people who might be watching the content from different part of the world. But point is, we are over here, and up is for us in this direction, and the down is in this direction. For a person who is somewhere over here, I guess that would be somewhere around along the Russian line, right? For them, the up is in this direction and the down is in this direction, right? So please understand, up and down is not the same as what we think. So all of them will point towards the center of the earth. So free fall, the direction is always towards the center of the earth. Now the magnitude part, what does that mean? But by how much force is it being pulled down? Well, let's begin by talking about Newton's second law. What does it tell, guys? The second law talks about force being equal to mass into acceleration. Okay. So yes, there are quite a few things that we will need to discuss in future, but I'm just giving you an introduction. So here, what is m? M is the mass of the object. And what is a? A is your acceleration due to gravity. Right? So that is the basic idea of force. Again, remember, we're trying to figure out the force. So this is the mass, that's the acceleration. But here, sorry, not acceleration due to gravity. You guys don't know what is that. Just acceleration. And this is a general formula. Now, for this particular scenario, I'm talking about a scenario wherein things are near the surface of the earth. A has a definite value. Near the surface of the earth. Near the surface of earth. A has a definite value and it's nothing but 9.8 meter per second square. I've seen this value somewhere. We have seen this in one of the problems. I told you guys to remember that. Try to recall. You have seen this value. Yes, right? So this is 9.8 meter per second. This was 9.8 Newton. That is an object which weighs 1 kg. What is the force that it experienced on the surface of the earth was the question. So this is what we got. Okay. So near the surface of the earth, acceleration is 9.8. And what they have done is, again, like all the stuff, it's given a special name. So it's denoted by this. What is denoted by? A is denoted by acceleration is denoted by this acceleration is denoted denoted by G. Okay, and it's called acceleration due to gravity. It's accelerating because of gravity, right? So it's called as acceleration due to gravity. That's it. Acceleration due to gravity of the earth. Okay, so this is something, all these are, how do you put it, set of information that you need to know. You just have to keep it in mind, right? So all of this has to be remembered. It's nothing much, it's quite simple, is it not? Any object falling towards the earth without the influence of any external force other than the gravitational pull, that is, it won't matter what was the initial condition, if it was thrown or there was an engine which was switched on and then switched off, right? We have how do you put it, air shows wherein we have fighter jet planes which goes quite a few to a particular altitude and switches off the engine and they start free falling, and of course for safety reason they switch on it again after they reach another altitude, right? Most of them, not most, quite a few air show they do that. So they are said to be under free fall, and for that moment of time, when there is an external influence other than gravity, then it's not said to be under free fall. Okay, a person in parachute is not an example of free fall, right guys? And anything else, right? Quite a few scenarios we discussed, all of them are under free fall. The definition has to be known. So please start with the definition, try to draw the diagram, and here too everything has to be written. Okay, everything is something that you guys have to know, memorize, right? It's nothing much, it's just a special name and a symbol and all of that, nothing else. Okay, so please pause and copy this as well.